Today we are going to be discussing the GATE 2026 syllabus and we will have a look at it. So first question arises that how to actually download the GATE 2026 syllabus. You just need to go towards a particular browser. I prefer Chrome, and just type in the URL that GATE 2026 syllabus, right, which is actually going to happen. And all of you friends just go for the applications. If you actually want to apply for the 2026 GATE application, the last date is just coming in this September only, so only some days are actually left. On just clicking and writing only for this stuff, right, you will be actually able to see the GATE 2026, which is actually being organized by IIT Guwahati this time. And if you actually go for this link or the other link, right, let me actually just move my say face here, my syllabus, right, as I just typed, right, you will actually find the first link in which you will find test papers as well as the syllabus of GATE for this particular year. Here you will actually be able to see multiple subjects, right, for your concern. So my specific area is computer science and applications, so I will go for this one and I will just hit click and then I will be able to download the particular syllabus. For your subject area, you will be able to download the syllabus from these respective subjects which are available out there. But for now, let's actually just focus on computer science because yeah, I actually specialize in that only. Okay, it will just download on your mobile, tablet, laptop, whatever, and you'll be able to have the PDF of that, as simple as that. Now let's actually have a slight small discussion about the key concepts and a little bit of things about the syllabus and how you must prepare for the GATE 2026 and what your strategy must be. Right. So you can see that you have different sections out there. One is actually this one. Let me actually put it on edit. Right, just close it and then just let me just do it. Okay, editing, right. Okay, so firstly you will have this section 1, that is actually engineering mathematics. Then you have the section 2 is digital logic. Then you have the computer organization and architecture. Then you have programming and data structures, algorithm, theory of computation, compiler design, operating system, databases, right. And then you have the computer networks. Now before actually going into the deep discussion about these particular topics, right, let's actually understand the patterns which actually is followed by GATE, right. Some of the questions will be actually from the aptitude section, right, which you need to cover from different websites, right. Other than that, there will be all major portion from a specific area like computer science and applications. So basically you will actually cover all this. There will be MCQ type question. Most of them will be MCQs, multiple choice questions, in which you will have multiple options from which one will be actually there. But some might actually even come for the calculation basis, like you might need to calculate the particular value of the particular question, right. So that you need to do. So you will need to practice both them. Some of them could be from computer networks, in which you might need to calculate the propagation delay for a specific bytes to be transferred and a particular segment size, right. And similar sort of question can also come for related to TCP segment. TCP is something maybe from operating system, maybe they ask for the turnaround time, related processes, and so on. So there is another book which you must also refer. I'm not any sponsor of that, but yes, I personally use that. That's actually by Made Easy. There's actually GATE sample papers. There's actually provides previous year questions in a collective fashion. You have all of them. You can try other. Other than that, we have multiple other resources, like there is a book by GATE Overflow, right, which also provides concise representation of what the questions, possible questions could be. But the main problems with most of the students, which actually arise, which I've seen in my students, is that they used to lack motivations, right, in actually studying for the GATE concepts, right. So do a group study, ask questions among yourself, try to get into the depth of the questions, right, and then you will actually learn better that if this actually changes, then what could be the possibility this could changes, then you will be actually able to cover a lot of such topics. Make groups, just ask questions from these topics only, right, from your friends and circles, right, and that's how you can actually learn better and faster. That's actually what I follow in my actually classes among my students. So let's actually just first talk about the discrete mathematics. You might have learned about discrete mathematics in your bachelor's and also in your entrance exams for preparing for a master's, right? Some of you might also have covered it into your master's itself, right? So it actually covers all these concepts: proportion and for sociology, FOPF. You might also remember that for all, for some statements, right? So okay, so there's actually relation to that. Then we have the sets, relation, function, partial order, lattices, monoids, groups, graphs, connectivity, matching, coloring, commuter, counting, recurrences, ratios, and generative function. By just having a look at these particular topics, you already must have got in mind that what could be the possible questions, right? Okay, let's for example take particular this recurrence relation. Just actually have a look at the particular topic and ask that if you were the examiner, that what could the question you might have made. If you have actually heard of this particular topic and might have just heard a little bit about it in your classes or anywhere else, then you can probably guess that what could you actually ask from the student, right? So think in this particular way. Note down the particular question which actually comes into your mind right after looking at the particular topic, right? So from my perspective, if I was a teacher, if I was actually a babysitter, what I could have asked a given particular function, right? I could have actually asked the student to solve this particular question, right? Solve the particular recurrence relation. I must have even given a function in the programmatical format. I must have given the code. I must have asked for deriving the recurrence relation for the particular function. I must have or might have even asked for, well, some well-known algorithm that derive the recurrence relation for that particular function. So you must actually practice in this particular fashion, right? Just go for the websites of the gate itself, right? Gate or flows of another website. So there's also a Stan Foundry website which I actually referred a lot, that actually consists topic by question. So if you actually go for Stan Foundry and just type gate whatever, or you must say reconciliation question, then you will actually get a lot of MCQ questions which you need to actually sit down and solve, and then you will actually find the solution to every such problem which could actually come into the gate in the upcoming era. Okay, so similarly, you might have also heard about coloring, right? Graph coloring questions, right? In which you have how many colors are actually required to actually color the graph, so that no two edges, no two connecting vertices which have an edge between them have the same color, right? That's actually a graph coloring problem, major, very, very famous, right? So you will actually be asked such direct questions also into gate, that how many colors are actually required. So you must actually learn the concept that how many maximum colors could be required, how many minimum colors could be required, and for what type of graphs. If you actually go for this particular resource on the jigs for jigs, right, there are, I think, another section which is consisting of last minute notes 11, pretty famous among the students, right, which they actually refer even a lot. It actually mentions different shapes of graphs, right, which have their unique properties, and after just deriving the particular shape and just getting that which type of graph it is, you will be able to get and nicely guess that how many colors would be required. So in this fashion, you must actually learn with the types and then deriving that particular number or the count of the particular colors which is required. Okay, you might be also the examiner also can turn the question a bit, right, and then ask again in the form of some math, right? They might say that there are some sort of say cities, and this city is actually adjacent to that, and this city is adjacent to that, right? And then they will ask that how many colors are required to color all the cities. Something like that question can be actually formulated. So you don't need to panic. It's just different formulation of the graph problem. You just need to consider it and just visualize all the cities in such form of say vertices, and then connect adjacent cities by edge. This is how you need to actually reformulate the problem into a graph problem, and then you will actually need to guess that which type of particular graph it is. It is a planar or is it something else, right? And then how you will actually get to know that how many colors required. One such example, simplest example, could be say 3 vertices, right? 1, 2, and 3. So for example, I will actually color this with red, I will color this one with green, and I will color this one with black. Okay, so what I can do, this is the maximum number of colors which I'm actually using up here, right? So can I actually do better than that, right? Okay, so if I actually just take another 3 vertices, the same vertices, right? But if I actually color this one to be red, but this one to be blue, and this one to be this one, right? So still the criteria is actually getting met, right? Is it so? If I actually connect the edges to be in such a way, is this a criteria actually and getting met? You need to actually check. So in this one, you see that the color between these two vertices is different, which is actually required by you. The color between these two vertices is also different, but the color between these two vertices is not different. right? So it is actually not verifying the particular property, and that's why you will need three colors, right? Now actually just consider another particular graph with graphs, right? So what if you actually taken a cycle of say four vertices, right? So what would happen, right? You have these four vertices, right? Now what would happen is that you want to color this particular all vertices. So what you can do is actually do red color here, right? Then you can actually do green color here, right? And then you can actually again do red color. Why? Sorry, there's actually the black one. I must take the red color, and then yeah, why can you actually take the red color again, right? That's actually because you have done red color here, but that's this vertex is not connected with this vertices, right? So by any means, that's why you can actually reuse your red color again. It's because you want to minimize the particular number of colors which you can actually use among your particular graph, right? Now can you actually use the green color over this vertex? If I do so, yes, it is possible, right? That then if you actually try to generalize this particular thing over the cycle of three vertices and the cycle of four vertices, then you will actually get to know that how many colors would you require for every such graph. So these all things actually generalize your statements that how many colors would you require in the graph coloring problem if you have say a cycle of odd number of vertices and a cycle for even number of vertices. Now what you can actually try is to do it for say 5 vertices and 6 vertices. 6 will be actually again even and 5 will be again odd. Now you will actually see a pattern that how many colors you are again requiring, right? And how many colors. That I will actually leave it for you and generalize the statement so that you can actually do it quickly when the exam question comes. And also the similar things actually comes up for the graphs like which are actually having mesh. What is a mesh? Is a particular graph in which all the vertices are connected, like this one, this one, this one, this one, and all are such connected among each other, right? Means it's actually kind of a mesh and having n into n plus 1 divided by 2 number of edges, or n into n minus 1 divided by 2. That's it. Okay, so similarly, you actually need to learn that what questions could actually come from different set of topics, right? Like they might actually ask the properties, right? That what are the properties of groups, right? What are the properties of monoids? What are the properties of say abelian groups? What are non-abelian groups, right? Something like that. They can actually ask in the exam. They might also give a particular statement that this is a particular function and whether this is a group or whether this is a monoid, whether this is abelian. So what you need to do is actually find those set of properties, right? Commutative, associative, and all, right? And then you can actually try finding whether all the properties are actually getting satisfied. So for that, you need to make a note-wise thing into your copy, right? Like you can make the notes of what the group properties are, right? Group properties are what is abelian, right? And I must tell you that there is a sort of sequence which actually comes among that if these sort of properties are only satisfied, then this becomes this particular thing. If another property actually adds to this set of properties, right, then this actually becomes not that, but along with that another thing which might be among from this group abelian and whatever, right? These are commutative, associative, and so on. A whole class would be required to devote on this particular topic of this engineering mathematics, but these are not as much as hard as they actually seems to be, right? You just need to tackle the exact questions which might actually come into exam, and also just clarify your understanding of what these things are and how they could be actually used in the real world applications. For example, the graphs, right? Graph coloring problem might be actually required when you are trying to share the resources among different cities, and the resource could not be shared among the adjacent cities. So how many minimum number of resources you would actually be requiring among the different cities over the world? That could be a possible application which you can actually think of. In the similar fashion, you can actually think of other different problems which are actually using this sort of principles. So you must try to relate with the applications that what it could be used with in the real world, so to actually make something useful out of it and make it something important in your life so they can actually remember that particular stuff. Okay, another thing comes from these relations function and all these properties which you might have studied in your 12th also, right? They again repeat themselves, right, in this level also. Yeah, they will properly repeat, and more the other properties of the relation and these functions, set properties which will also be asked from this particular topic, right? You and propositions and for here for sort of logic, right? You might be asked that some questions, right? These some questions for all question, right? You might be given a particular statement, you might be asked to convert it into this propagation logic that okay, so one such example which is pretty famous in the gate exams which I've seen is that okay, if every person has only one mother, right? That's actually one particular example, right? So what actually you used to do is actually you have to take for all, right? For all child, if y is mother of, and for some y, right? Okay, if some and you will be actually given some functions like equals, and then mother of xy, right? X is mother of y, right? And then you will actually use the equal sign, right? So you will actually first build logic, right? That how can you can actually represent it. So the one of the basic logic in which it can be represented is that if x and y are actually same person, right? If x and y are actually same person, then their mothers would be equal, right? So you can actually represent this way by using these sort of operations, right?